All right, so here's another lesson with transformations. Today we're going to look a little bit more closely at K. So let's go through. But of course, we need to start with our joke. How appropriate for this time of year. How do you keep warm in a cold room? You go to the corner because it's always 90 degrees. All right, so what do you remember? A is the vertical stretch or compression. Also, if it is less than 0, it is a reflection in the x-axis. If our absolute value of A is greater than 1, then that will be a vertical stretch. And if our absolute value of A is between 0 and 1, then it's a vertical compression. And now C. What do you remember about C? C is the vertical translation up or down of the entire function. Next, we looked at D. What does D do? D is the horizontal translation from left to right or left or right. The last one we're going to talk about is K, and we will spend some more time on that one today because we didn't really use K when we were working with parabolas last year. But what do you think K is? K will be the horizontal stretch or compression, and if it is less than 0, it will be the reflection in the y-axis. So it is the equivalent to A, only working on the x values instead of the y values. A works on y and K works on the x values. This summarizes our general transformation function, and we'll be using this throughout the entire course. So what about K? K is about horizontal stretches and compressions. If you can imagine our parent function being the red function, then a stretch is pulling it from side to side. So our horizontal stretch looks something like a vertical compression, at least for this function. Our stretches, unlike the vertical stretches, we will have a horizontal stretch when our value of K is between 0 and 1. Compressions. So if you can imagine that our red function is the parent function, okay, so now we're on horizontal compressions, and you can see these men pushing on either side of our function. So the red function is the parent function, and we're squeezing it towards the center, so from each side. So that's a horizontal compression. And it happens when K has a value bigger than 1. So again, our horizontal compression for this particular function and for some of our functions kind of looks like a vertical stretch. So just exactly the opposite. So horizontal compression has a value bigger than 1. And remember, our vertical stretches have a value bigger than 1. So to summarize that, if K is bigger than 1, that is a horizontal compression. And we're going to squeeze the function towards the center. And if our value of K is between 0 and 1, that's horizontal stretch. And if our value of K is less than 0, then it's a reflection in the y-axis. So to be more specific, let's look at our parent function of y equals the absolute value of x. So right here, the black dotted line is y equals the absolute value of x. I've chosen 4 points. Choosing the point 0, 0 isn't really very helpful because that's going to be the same on all three of the functions. So I chose these 4 points on the original function. 2, 2, 4, 4, negative 2 with 2, and negative 4 with 4. I'm going to see what happens to these points as I apply a horizontal compression where k is greater than 1. So the k value is 2. And what that is doing is it's working on the x, because it's hanging out here inside with the x. So that's how we know it's k, because it's hanging out with the x. And we're going to end up dividing every x value by 2. So instead of multiplying our x values by 2, we're actually going to divide them, doing the opposite of what we see. We see a multiply by 2, and we're going to divide by 2, but only the x values. The y values will stay the same. So looking at this ordered pair, I keep the y value of 4, and now I'm going to compress by dividing the x value by 2. And the k is 2, so I divide by 2. I'm going to do that with the second point over here, where negative 4 is divided by 2 to get negative 2, and keep the 4. So I'm only working on the x right now. Try it with the other 2 points. So 2 becomes 1 for our x value, and negative 2 becomes negative 1 for our other x value. So we're working only on the x. We're keeping the y's the same. This is horizontal compression. Our k value is 2. Effectively, what we were doing, it says here multiply each x value by 1 over k. That's the same as dividing by k. So if we think that we're going to just divide by k, no matter what k is, then that's how we're going to get our new function. Now looking at horizontal stretch, we're going to again start with the function y equals the absolute value of x. And we're going to stretch it out to the green one here. So you can see if we're going to stretch, we're going to take this point and we're going to stretch it over here, keep the y value the same, and stretch the x value. We're going to do that by dividing by k. Well, k is a half this time, and dividing by a half is the same as multiplying by 2. So keep the y value the same because I'm stretching this out to here, and our x value becomes 8, 4. So I only worked on the x. Similarly, on this side, I am stretching from the black function over to the green function, and because it's a k value, I'm only working on the x, and I multiply by 2. So even though my k value is a half, I'm actually dividing by a half, which is the same as multiplying by 2. Similarly, with our 2 lower points, this 2, 2 goes to 4, 2, and negative 2, 2 goes to negative 4, 2. In each case, we divided by a half, which is the same as multiplying by 2. This is horizontal stretch. Yes. And I guess that's it for now. Good luck. We'll talk more about it in class.